Okay, so continuing with 6.4. Let's do number 3, which is tangent to the fourth of phi minus 2. Let's do secant squared of phi tangent squared of phi plus secant to the fourth of phi is equal to cotangent squared of phi. Okay, so actually let me move this down one line. Okay, so let's rewrite this in blue. So we have tangent to the fourth of phi minus 2. Let me write this as tangent squared phi secant squared phi plus secant to the fourth of phi is equal to cotangent squared phi. So what we have on the left is we have the difference tangent squared phi minus secant squared phi all squared. It's a perfect square trinomial. Is cotangent squared phi. So taking the square root of both sides, let me copy. Actually, before I do that, let's notice something. What do I know about tangent squared and secant squared? Well, I know I have the identity 1 plus tangent squared phi is equal to secant squared phi. So I claim that tangent squared phi minus secant squared phi is negative 1. So I can actually rewrite what's inside here as negative 1. Quantity squared is cotangent squared phi. Okay, well, negative 1 squared, of course, is 1. Is cotangent squared phi. However, when I take plus or minus the square root of both sides of this equation, I get that cotangent of phi. So cotangent of phi, let's do phi in hot pink, is plus or minus 1. Okay, so those values of phi between 0 and 2 pi, where cotangent is positive 1, is at pi over 4, and 5 pi over 4. And those values of phi where cotangent is negative 1 is at 3 pi over 4 and 7 pi over 4. Okay, so how about one more for good measure? So number 4, let's do cosine of the quantity pi over 2 minus phi times secant of theta. What did I say? Phi, theta, is equal to the square root of 3. Oops. Okay, so rewriting this, we have cosine of pi over 2 minus theta times secant of theta is equal to the square root of 3. Okay, well, cosine of pi over 2 minus theta is the same as sine of theta times secant, which is 1 over cosine, and that's the square root of 3. So sine over cosine is tangent. So we get that tangent of theta is root 3. Okay. So the two angles will be in quadrant 1 and 3. So that corresponds to sine being the larger one, so pi over 3, and 4 pi over 3. Okay, so let's recall. So given a right triangle right triangle ABC. Triangle ABC. So let me go ahead and draw a right triangle ABC. This is A, B, and C. Let's call this little side A, little side B, and little side C. Let's call this angle theta here. So what do we have? Have the sine of angle theta. Well, that's going to be the side opposite over the hypotenuse, which means that cosecant of angle theta will be the reciprocal to that, which is hypotenuse over opposite. We have that cosine of angle theta is going to be adjacent side B over the hypotenuse C, which means that secant, the reciprocal, secant of theta will be hypotenuse C over adjacent B. And last but not least, we have the tangent of angle theta will be, actually instead of green, I'm going to make this orange, or yellow. How about yellow? So tangent of theta is going to be opposite over adjacent, A over B, which means the reciprocal cotangent of theta will be adjacent B over opposite A. Okay, so now that we have that, let's use that to evaluate the following. So, example. So use triangle trigonometry to evaluate the following. Use triangle trigonometry to evaluate the following. Okay, so number one, we have sine of secant inverse of, and here's where we'll need our triangle, the square root of 81 plus x squared, all divided by x. Okay, so how do we deal with this? We always let theta be the inverse function. So our first step is to let theta be secant inverse of the square root of 81 plus x squared all over x, because that's equivalent to saying regular secant of theta is the square root of 81 plus x squared all over x. Let me draw that higher. All over x, which of course is equivalent to saying cosine of theta is x over the square root of 81 plus x squared. Okay, so now I'm going to draw a triangle. So any right triangle, and let's have angle theta be here. So what do I know? Cosine of the angle is adjacent side over hypotenuse. Okay, so it must be the case that the other side, if the square of the opposite side is 81, then the opposite side must be 9 in order for that to be true. Okay, so now let's go back to the beginning. We have sine of secant inverse of the square root of 81 plus x squared all over x, but that is theta. I called that whole inverse secant just theta. Well, what is sine of theta according to this triangle? It's opposite 9 over hypotenuse, the square root of 81 plus x squared. Okay, so there we are. Let's do another one. Okay, so number 2. Let's evaluate cotangent of inverse sine of the square root of 25. I don't like that square root symbol. Square root of, let's do 25 minus x squared all over 5. Okay, so once again, I'm always going to let my angle theta be the inverse function. So let theta be inverse sine of the square root of 25 minus x squared all over 5, which is the same thing as saying sine of theta, regular sine, will be the square root of 25 minus x squared all over 5. So let's go ahead and draw a triangle. And let's have my angle theta be here. And I know sine is opposite side. So the square root of 25 minus x squared over hypotenuse 5. So that must mean that the other side is x. Okay, so rewriting this, we have cotangent of inverse sine of the square root of 25 minus x squared all over 5. But that whole green expression is theta. So cotangent of theta is going to be adjacent x over opposite the square root of 25 minus x squared. And there we are. That's how we evaluate that guy. Okay, so one more at least for good measure. So actually I don't like the way that looks. It's not straight. Let me make this a bit straighter. Okay, so let's put a straight line. Let's do x in the numerator. Square root of, let's do 25 minus x squared in the denominator. That looks a bit better. Okay, so number 3. Let's evaluate cosine of inverse tangent of, let's do 7 over 3x. Ugh, terrible. Okay, so once again, the first thing I want to do is let my angle theta be the inverse trigonometric function. Okay, because I want to rewrite this without inverse trig functions. So I want to rewrite this as normal tangent of theta is going to be 7 over 3x. So now I can draw my triangle. So right triangle. Kind of, it's not really a straight line. Let's see. There we go, much better. Okay, so we have our angle theta, and I know that tangent is opposite 7 over adjacent 3x. So I claim that the hypotenuse is going to be 9x squared plus 49 underneath the radical, using the Pythagorean theorem. Okay, so now let's rewrite this. We have cosine of inverse tangent of 7 over 3x, which is really cosine of theta. Okay, so looking at our triangle, cosine is adjacent 3x over hypotenuse, which is the square root of 9x squared plus 49. There we are. I think we did it. Okay, hopefully this makes sense.